Let's calculate the domain of a function f of x equal to the square root of minus x squared plus 5x minus 4. The domain is the biggest set of real numbers where the function, that is the square root of minus x squared plus 5x minus 4, has sense. But the question is, when does a root have sense? A root has sense when what is inside of it is equal or bigger than 0. The square root of 0 is 0, so the 0 would have sense. But when it is a negative number, it is impossible because there's not a square root of a negative number. So let's study the sign of the polynomial inside of the root. To study the sign of minus x squared plus 5x minus 4, we have to make it equal 0. And now let's calculate the values of x when substituted on the polynomial are equal to 0. Applying the formula for the second degree polynomial, we will have the term with the x squared is minus 1, the term with the x is 5, and the independent term is minus 4. So let's go with minus b, that is minus 5, plus minus the square root of b squared, 5 squared, minus 4 times a times z, that is 4 times minus 1 times minus 2, divided by 2 times a, that is 2 times minus 1. And from here we have minus 5 plus minus the square root of 5 squared is 25, and now minus times minus is plus, times minus is minus, and that is 4 times 1 times 4 is 16, so minus 16 divided by 2, minus times minus 1 is minus 2. This is equal to minus 5 plus minus the square root of 9, that is 3, divided by minus 2. And from here we would have two different results. Minus 5 plus 3 divided by minus 2, and minus 5 minus 3 divided by minus 2. Minus 5 plus 3 divided by minus 2 is 1. And minus 5 minus 3 divided by minus 4 would be minus 8 divided by minus 2, and that is plus 4. These two are the values that makes the polynomial equal 0. That is what is inside of the root. So these values are going to be on the domain because they make the polynomial equal 0, and it is possible to obtain the square root of 0, which is 0. So let's draw them on a straight line, and here we have the 1 and the 4 with points. That means that they're included on the domain. Now we're gonna calculate the sign on each of these 3 intervals. And to calculate this sign, what we have to do is to get a value smaller than 1 for this first interval, that is 0, a value between 1 and 4, it could be 3, and a bigger value than 4, that is 5. The function we're going to study, the sign is a polynomial, and that is a continuous function. So that means that the sign is gonna stay the same for the whole interval. Let's go with the 0. Minus 0 squared plus 0 times 5 minus 4, that is minus 4. Let's substitute the 3, and we would have minus 3 squared plus 5 times 3 minus 4, and that is equal to, be careful with this, we have minus 3 squared, but the square only affects to the 3, not to the minus sign, because there's no parentheses. So let's copy the minus, and the square of 3 is 9. Be careful with that. 5 times 3 is 15, and now minus 4. Operating this, we would have 2. That is a positive sign. And let's go with the third interval. Minus 5 squared plus 5 times 5 minus 4. This would be equal to minus 25 plus 25 minus 4. And that is again minus 4, a negative sign. Now we can write the domain of f. The domain of f are those intervals where substituting the polynomial minus x squared plus 5x minus 4 is bigger or equal than 0. So as 1 and 4 makes the polynomial 0, they are included on the polynomial. So the domain would be from the 1 till the 4 included on the domain.